Actually, this one is summer 18 question paper. So this one is summer 18. And the question paper is 1-2. So anyway, so the compound Y is treated with an excess of hydrogen in the presence of a nickel catalyst. The product is fully saturated. So what is the total number of chiral carbon atoms in the product once the hydrogen has been added to it? So what happens? What happens when hydrogen gets added? The hydrogens are going to get added to the double bond, right? Hopefully everyone knows what hydrogenation is. So all these double bonds would go away. And instead, in their place, you'll have hydrogens getting added, right? So all these double bonds, they would go away. And the carbon would become fully saturated. Is that clear? Tanya, is this clear? This one?
Yes, sir.
So what is the total number of chiral carbon atoms? Now let's start looking for the chiral carbon atoms. So this one has 2 H's. This one has 2 H's. This one has 3 H's, right? This one has 2 H's. So I'm marking out all the carbons that are not chiral. So 2 H's, 2 H's. This one has 3 H's, 2 H's with this one, 2 H's, 2 H's. This one would also have 2 H's. Now let's focus on this one will also have 3 H's with it. This one over here will also have 3 H's. This one also it also has 3 H's, right? So let's focus on the ones that are chiral now. So I think this one looks chiral, right? How many hydrogens with this one? With this one?
1.
Okay, so there's going to be 1 hydrogen. So, and all 4 sides, they look different. I mean, this side is this thing, this side is this thing. So all 4 sides are different. So this one is definitely chiral, this one. So what else? Is this chiral, this one? How many H's with this one, right?
हाँ सर वो एक H होगा.
Okay, so this is chiral, right? It's got a CH3. On the right side, it's all this thing. On the left side, so all 4 sides are different, right? So this one is also chiral. This one over here also kind of looks chiral because this one, the one that I'm marking, this one, it's also going to have 1 H, right? So it's going to have 1 H, and all 4 sides, they look different. This side is this thing, this side is this thing, this side is this thing, and there's 1 H. So all 4 sides are different for this one as well. So that is also chiral. Is this chiral, this one? Or not? So there is this Oswald Reed. This one.
सर सर इसकी शर्त ये है कि लाइक डायरेक्टली जो बॉन्ड हो ना वो एक होना चाहिए बेशक उसके जो साइड ब्रांचेस जो हो वो जो भी हो
नहीं उसका ये कि बस all side must be different. I mean, for example, if you're looking at this one, right? If you're looking at this one, this is chiral, right? So you don't just look at the one that is directly bonded to it. You have to look at the whole side. Is the whole side different or not? Like if you look over here, there's an H. On this side, it's this entire thing. So it's different compared to this side, which is slightly different. This side, which is slightly different. Is that clear? So you have to look at the whole side. Is that clear?
Yes, yes, sir.
So you've got to look at the whole side. So we were at this point. This is no Sidra. It's I mean I was talking about this one. This one is not chiral, so I'm putting a cross on it. Why? Because it's got a CH3 and it's got another CH3 over here. Is that clear? Sidra, is this clear? Sign clear? This one. Tanya, is this clear?
Yes, sir.
Yes, sir.
Okay, so that one is not chiral. What about this one over here? It's going to have this one over here. It's going to have 1 H, right? So this one over here has this side is this thing. This side has this entire thing, which is different. The top side has this thing. So all 4 sides, like if you're standing on this, all 4 sides, they look different. So this one I think is definitely chiral. And who else? I think this is chiral, this one. Okay, so this one has 1 H as well. So if you're standing on top of this, all 4 sides, they look different. CH3 on one side, H on one side. So all four sides are looking different. So that one is chiral as well. And apart from that, I don't think there's any other chiral, because all of them have multiple H's. So they can't be chiral. So that's 1, 2, 3, 4, 5. So 5 is the answer. Is that clear?
Yes, sir.
So now the next part is about the next part, which equation represents a valid
B.
propagation step in the chlorination. So B is not correct.
Yes.
No,
Is it?
no,
Oh.
B is not correct. What happens in propagation is, I mean, this is what happens in propagation. Where's the notes? Just a second. So propagation, we just did this. 1 second. Hopefully it's here. So where's propagation? This is. So in free radical substitution, let's just quickly go through this. In free radical substitution, you had the Cl radicals getting produced in the first step, and homolytic fission happening, right? Homolytically bond breaking. So next step was propagation. So in the propagation step, this is what happened. That a Cl radical, which is a very reactive species because its bonds are not complete, it's going to steal one of the hydrogen atoms. So hydrogen, instead of sharing electrons with the carbon over there, would start sharing electrons with the Cl over here, and it would form HCl. And the carbon would then become a radical because its bonds are now no longer complete. The carbon radical would then attack a Cl2 molecule and steal one of the Cls and bond with it, and the Cl radical would be again formed. And this step just repeats endlessly. The Cl radical that has formed would attack the chloroethane now and steal one of the hydrogens and bond with it, HCl, and the carbon would become a radical again. The carbon radical would then attack the Cl2 molecule, would steal one of the Cls and bond with it, and another Cl radical would be produced. And again, repeat, it's going to be Cl radical attacking one of the hydrogens, forming HCl. The carbon would become a radical again, so on. So the thing is, in free radical substitution, a Cl radical, why is B not correct? Because a Cl radical is going to come in. It's going to attack or steal one of the B is correct, actually. I'm sorry. It is correct. It is correct. B is correct. I did not see a Cl was already in place. Okay, so I'm wrong. B is perfectly right. So this is what is happening. A Cl radical is coming in. It's stealing one of the hydrogens. And so there's C2H4. The hydrogen goes and forms HCl. And this molecule is now a radical. The carbon in the molecule is a radical. So they've actually written the condensed version. So one of the carbon would be a radical. Is that clear?
सर
हाँ.
सर आपने कहा था कि हाइड्रोजन कभी रेडिकल नहीं बन सकता, लाइक इस तरह से है, इसकी कोई रीजन है इस तरह से?
उसकी रीजन ये थी कि when I said कि a hydrogen radical is never formed, उसकी reason termination step. In the termination step, I told you that a hydrogen radical is never formed or produced, because if it had been produced, then two hydrogen radicals could have gotten together to form an H2 gas molecule. And so far, we don't have any evidence of H2 gas ever forming. Is that clear?
Yes, sir.
So these are all automatically incorrect. This is a termination step. So this is correct. This one over here is a termination. It's a termination step, right? So that is termination. So anyways, next one, you've got this molecule, and so it is the cis isomer of butane dioic acid. So remember, he's saying that malic acid is the cis isomer of this molecule. It is the cis isomer of butane dioic acid. What is the product formed from the reaction of malic acid with cold dilute acidified magnate 7 ions? So he's talking about mild oxidation. So did we do mild oxidation? I think we did. Did we do mild oxidation?
Sir, I guess नहीं किया हम लोगों ने.
We didn't. We did. So we'll quickly do that. Now, we 1 second. So we had done we actually did the whole primary alcohol oxidation. We didn't do alkene oxidation. So let's quickly do that. So oxidation of alkenes. Okay, let me just, so I can make pages at the end. Just 1 second. Hold on 1 second. It's still stuck. So alkenes and their mild oxidation. 1 second. So alkenes and redox reactions. Now, not sure where's 1 second. So redox and alkenes. Alkenes undergo 2 types of oxidations. One of them is known as the first one. That one is known as mild oxidation. Now, what happens in mild oxidation is that you use the conditions first. You've got cold, dilute, and at times alkaline KMnO4. So those are the conditions. Now, mild oxidation is, that is simple, that if you have an alkene, it's like an addition reaction. So if you have an alkene, you've got a double bond, and you've got carbon with hydrogen atoms, right? And the oxidizing agent is sometimes written as O. They won't ask you for the equation that much. I mean, they might ask you, but remember the actual KMnO4 equation is slightly complicated. So they use O as an oxidizing agent in a lot of equations, just to simplify things. Because the actual equation with acidified KMnO4, it's kind of complicated, and it's hard to even remember, and really hard to actually make it like a normal reaction. So you've got an alkene. Everything would remain exactly the same. The reaction is with a double bond. So whenever you see a molecule and it's got these double bonds, there's going to be an addition of so there's going to be an addition of OH groups on this double bond. So the double bond will turn into a single bond, and OH groups will get added to both carbon atoms that were previously making these double bonds. So it's a reaction of these 2 carbon atoms. Is that clear?
Yes, sir.
चलो हाँ जी
सर आप ये फिर से एक्सप्लेन कर सकते हैं?
नहीं बस एक्सप्लेन करने को कुछ नहीं है, बस ये कि mild oxidation is when you have cold dilute alkaline KMnO4. I mean, you don't need to learn the mechanism, or you don't need to learn the reasons for the reaction. All you have to know is when there's going to be oxidation with dilute KMnO4, which is mild oxidation, mild conditions, cold conditions, dilute. You have an alkene, the double bond would turn into a single bond, and OH groups will get added to it, and diols are going to be produced. Clear?
यस सर. और सर वो आपने सिर्फ ओ मेंशन किया, वो इस तरह से लिखेंगे एग्जाम में?
नहीं, एक तो पहली बात है वो लिखने को कहेगा नहीं, मतलब वो most of the, like remember in organic chemistry they ask for equations very rarely. I mean, they can ask for equations, but very rarely. Most of the time they're just looking for products. But I'm just saying that sometimes, and they're not going to ask for the equation for KMnO4. Remember, KMnO4 equation is like really complicated. For example, if I actually give you an equation, you wouldn't even be able to remember this. No one would be able to remember this. Like equation for KMnO4 plus, let's say, propene. I mean, if I can find this find this equation on the internet. It's so it's this one, right? I mean, you have this equation in front of you. You can't remember this. I mean, it's impossible to remember this. And this one is, I think, in cold conditions. So remember, they're not going to ask or look for equations. They'll just ask you for the products. But sometimes what they do is, instead of actually involving KMNO4, they simplify the equation. They simply, what does an oxidizing agent do? The oxidizing agent provides oxygen. So sometimes what they do is they just put an O in place of the oxidizing agent, an O in square brackets. Okay, is that clear? This O represents KMNO4. Okay, let me put an arrow there as well. So this oxygen over here, it represents this O. Is that clear?
Yes, sir.
And you can balance this equation. Now this one is a lot simpler to balance. Instead of actually, I mean, you can't memorize this. No one can memorize this. So instead of having that equation, this is a lot easier to memorize. And when you're writing it with O, make sure if you're running out of hydrogens or you need oxygens, you can add water on both sides. In this case, I think you would have to. There are two oxygens getting added, right? So I think you would have to add water. There's hydrogen adding as well. So make sure you use water for balancing. You can add water on that side, or you can also add water on the other side as well. But it's going to be very rare. Very rare would they look for an equation. So don't get confused when you see an O. If you ever see an O, most likely you will not see this equation. The only thing you'll see is a reactant and the product. That's it. Is that clear?
Yes, sir.
Okay, so this reaction is kind of simple. I'm going to make it slightly more complicated with the skeletal formula. So let's say I've got a skeletal formula, and the skeletal formula has double bonds, and it's got so there's this other double bond. So what you have to do is find the product that would be for the mild oxidation. So the product of mild oxidation, this is an alkene. So all you got to remember is everything kind of remains the same. OH groups are going to get added. So the double bond, and remember, focus is on these carbon atoms. So both double bonds would be removed. So that's gone, and in their place, OH groups are going to get added to both carbon atoms. So OH groups, this one as well, there's going to be an OH group and an OH group added. So that is what a diol would look like. So that's your product of the reaction. Is that clear? Wherever you see double bonds, just put OH groups in their place. Is that clear?
Yes, sir.
हाँ
सर
जी.
लेकिन यहाँ पे दो लाइक डायोल्स आ जाते हैं ना यहाँ पे आपने
अच्छा नहीं
फोर
उसको
लगा
हाँ उसमें confusion में पढ़ो diol. I'm just talking about diols in the sense that a double bond and two H groups get added. ठीक है. So obviously this is a tetraol. That's not a diol. ठीक है. Is that clear?
yes
So I was just saying, like, if you had one double bond, then it's going to result in a diol. If there's another double bond, that's another diol. So that's four OH groups now. अच्छा anyway, so that's
तो
kind of
सर तो
हाँ हाँ
दो डबल बॉन्ड्स के चार डायोल्स होंगे ना
नहीं मतलब
और वन
चार OH groups ना.
ओके और
पर छोड़ दो
वन डबल बॉन्ड के टू
हाँ मैं डायोल छोड़ दो. डायोल को दिमाग से निकाल दो. बस डबल बॉन्ड की जगह ना you will have OH groups getting added to it. ठीक है. So next one. Okay, the next one is difficult and it's tricky, which is strong oxidation. Okay, the next one requires some sort of I mean, you have to really think a lot for the next one. So the next one is strong oxidation of alkenes. So So strong oxidation of alkenes is first thing conditions. It's going to be hot, concentrated, and acidified KMNO4. So stronger conditions, hot, concentrated, you're heating it. And remember, KMNO4 is a really powerful oxidizing agent. Potassium magnate 7. So what happens in this case? The very first thing that you got to remember is, in this case, the double bond will not turn into a single bond. The first thing that will happen is that the double bond would completely break. There's not going to be anything. It will completely split. The molecule will split into two pieces. So the molecule is going to split from the middle into two species, two separate species. So double bond completely breaks. So it completely breaks and molecule splits. So now you have two pieces, two completely separate pieces. So you're not looking at one product now, you're looking at two products because you have two separate pieces. And there'll be three scenarios. So what will happen to this carbon atom? That's the question. What's going to happen to this carbon atom? There are three scenarios. Number one, if the carbon that was making the double bond, and remember, everything is happening to the carbon that was making the double bond. Nothing should happen to the rest of the molecule. We don't care about the rest of the molecule. Nothing should happen to it. So just the molecule splitting at the position where the double bond was. And this carbon would change into, there are three scenarios. One is that if this carbon is bonded to two H's, then this carbon atom will get oxidized by KMNO4 to carbon dioxide. And once the carbon has split up, it's going to turn into CO2 and H2O. That's scenario number one. The second scenario is, what if this double bond specifically had a carbon chain and an H on the other carbon atom? So what if it had a carbon chain? So this one, I mean, this molecule over here, and specifically this carbon atom over here, will first change into an aldehyde and then turn into a carboxylic acid. So it will first turn into an aldehyde, and then it will, so that's, so first thing is, it will first turn into an aldehyde. There's going to be serial bond O. And then another O will get added. This H will turn into OH. So it will turn into an aldehyde and then a carboxylic acid. And then carboxylic acid. And then you have a third scenario. The third scenario is that the double bonded carbon atom had two carbon chains attached to it. So this one, just a second. Okay, so this one would turn into a ketone. So it would turn into a ketone. So they're basically three scenarios. So we'll do some examples. So this carbon atom can turn into three different things depending on what's attached to it. So it can turn into three separate things, depending on what's attached to it. Now counting H's is difficult because in skeletal formulas they don't show H atoms, so it's a lot easier to actually count the carbon chains. So the easier way to remember this is so the relatively easier way to remember this is that if the double bonded carbon atom has two carbon chain, it turns into a ketone. If the double bonded carbon atom has one carbon chain, it turns into a carboxylic acid. The reaction is not going to stop at aldehyde. And if the double bonded carbon atom has no carbon chains, it turns into carbon dioxide and H2. So I'll do an easy example, a couple of easy examples with displayed formulas first. So I've got a molecule, and that molecule has, let's say it's a butene, and there's an H and an H. So first thing, one by one. So that's the first example. The one thing you should remember is, so that's example number one. The double bond is going to completely break. And remember, the focus is on these two carbon atoms. What will happen to these two carbon atoms? Nothing should happen to the rest of the molecule. I mean, the CH3 should remain exactly whatever it's like. It should not change. So the molecule is split into two pieces. So let's split the molecule into two pieces. So that's one piece going in that direction, and that's the other piece that goes in the other direction. So the molecule has split up and it has produced these two pieces. And the two pieces are exactly the same, by the way. So there was a double bond here, and the molecule has split up. So which scenario is this? The double bonded carbon atom. Let's focus on the carbon that's in the red.
Aldehyde.
Okay, so it's got one carbon chain and one H. So it's got one carbon chain. So if it's got one carbon chain, it will turn into an aldehyde and then a carboxylic acid. The other one is exactly the same. So both of them would produce the same thing. So this carbon, the double bonded carbon atom, remember everything should happen to this one. So it would turn into a carboxylic acid eventually. So you're going to do just that. You're going to do just that. You're going to make it into double bond O and OH. It will turn into a carboxylic acid. The other one would also turn into double bond O and OH. It will also turn into a carboxylic acid. Is that clear? And that's ethanoic acid basically. So you're going to get molecules of ethanoic acid.
Sir?
हाँ जी.
सर आप इसको aldehyde में convert नहीं करेंगे?
नहीं जरूरत नहीं है क्योंकि it's strong oxidation, a hot concentrate, so the reaction is not going to stop at aldehyde. So there's no point stopping the reaction at aldehyde. What I can do is, the aldehyde is just written as a, I mean, it's very rare that it actually stops at aldehydes. Maybe in the question, maybe sometimes they might give you, they haven't actually done this, but they might stop the reaction at aldehyde. But most likely the reaction is not going to stop under extreme conditions. Hot concentrate KMNO4, it would eventually form a carboxylic acid. Is that clear?
Yes sir. Sir, इसके अंदर वो scenario तो नहीं आ सकता ना? Heat under reflux और वो distilled water.
अच्छा हाँ, वो that one. So remember, for alcohols we did study this. That for alcohols we did study that you can stop the reaction at an aldehyde if you use distillation instead of reflux, and the aldehyde would evaporate. But the thing is, K2Cr2O7 was a slightly milder oxidizing agent, and the reaction was not, I mean, K2Cr2O7 was the primary reagent in this reaction. So you can kind of stop at aldehydes, but remember you're doing strong oxidation. So even then, it's if you're using hot concentrated acidified KMNO4 and you're using concentrated KMNO4. So it's pretty rare that the reaction would eventually stop at aldehydes. It's going to be a quick reaction all the way to carboxylic acid. Point clear?
Yes sir.
क्योंकि conditions थोड़ी सी ज़्यादा extreme है. It's concentrated KMNO4 as well. So there is a possibility that it might stop at aldehydes, but it's a lesser probability. So now let's do another one. Okay, let's do quickly another one. Let's do the second example. We've got another molecule. And this molecule is, so the second molecule looks like this. It's CH3, there's a carbon atom, double bond. Carbon atom, there's a branch of CH3. And you've got 2 H's. So again, what will happen? The first thing is everything should happen to these 2 carbon atoms. So the double bond would break in the middle, and you're going to get 2 pieces. Okay, what are the 2 pieces? One of them is this one. So one of them is this one, and the other one is this one. So you're getting 2 pieces. So let's talk about the right one. What if you have carbon with 2 H's? What would it form? It's going to form
carbon dioxide.
Okay, so it's going to form carbon dioxide and H2O. So this thing should turn into CO2 and H2O. And what about the other one? It's got what should this turn into?
Ketone.
Okay, so it's got 2 carbon chains, so it should turn into this one should turn into a ketone because 2 carbon chains, so the carbon atom would just get an oxygen. So you don't even have to do that. Just put oxygens there. So you've got an oxygen there. It's going to turn into a ketone. Is that clear? ठीक है everyone is हाँ Mahad is
सर ये एग्जाम टाइप क्वेश्चन कैसा हो सकता है इसका?
नहीं वो तो भी करते हैं ना अभी तो आसान वाला किया है. Aisha, clear is Umar is Wasfa?
Yes, sir. Yeah.
Okay. So the next is, let's try and do more difficult questions. Let's think of a more difficult question. Let's say we have a skeletal formula now. Okay, and a slightly more complicated skeletal formula. Now remember, make sure you remember this. Okay, 2 carbon chains with the double bond, it's got that's a ketone. 1 carbon chain, it's a carboxylic acid. No carbon chains, that's carbon dioxide and H2O. So let's do a skeletal formula. So I have this complicated molecule, and so let's say we have and we've got another double bond here. So let's try and do this one. Now the first thing is, this one. So first thing is break all the double bonds. That's the first thing. And remember, I'm talking about strong oxidation. Mild oxidation is easy. You just put OH groups. So you've got all these carbon atoms. I'm going to break the double bonds. And the bonds are going to break completely. So focus on these carbon atoms. This one. The rest of the molecule, nothing should happen to it. And the double bonds are going to break. So double bonds are gone. This one is gone, right? So let's focus on what happens to these carbon atoms. So this one has 2 carbon chains. What should this get converted into if it's got 2 carbon chains?
Ketone.
Okay, so that will be a ketone. So I'm just going to put a double bond, and I'm going to put an oxygen on it. I said this one, it's got 1 carbon chain. So what would it get converted into?
Carboxylic.
Okay, so this one should get converted into a carboxylic acid. So there is which double bond O and which. So what about so what about this one? 2 carbon chains.
Ketone.
Okay, so that's going to be ketone and double bond O. What about this one? No carbon chain.
CO2 or H2.
Okay, so if it's got no carbon chain, that should get converted into CO2 and H2O. So that is how you're going to decide. And remember, nothing should happen to the rest of the molecule. It's only the reaction is only happening with the double bonded carbon atoms. That's it. Nothing should happen to the rest of the molecules. Let's try and do another one, similar question. Let's say I have so let's say there's this and this. So let's say this is the molecule, and it's got 3 double bonds. So I'm going to try and figure out what's going to happen to it. First thing, all the double bonds are going to break. So the double bonds would all of them would break. This one would break. This one would break. This one would also break. All of them should break. So let's break them all. And the focus is on the double bonded carbon atoms. So I'm going to remove the double bonds. This is gone, this is gone, this is gone, right? So I'm getting these, and it's get them slightly separated. So the focus is on the carbon atoms, the ones that I've marked that were making the double bonds. Is that clear so far? What should this turn into?
Ketone.
Okay, so that should turn into a ketone. It's got 2 carbon chains. So what should, let me get this over here. What should this turn into?
Carboxylic.
It's got 1 carbon chain, 2 carbon chains.
Oh, ketone.
Okay, so this one would be ketone. What should this turn into? Your bottom pair. This has 1 carbon chain.
Carboxylic.
Okay, so this one would be carboxylic acid, and maybe this one is 1 carbon chain, so that's carboxylic acid. This one has 2 carbon chains, so that's ketone, right?
Ketone.
What about this one, the last one? That is
CO2 plus H2.
okay, no carbon chains, so that's CO2 and H2O. So it's not that difficult. You just have to remember that break the double bonds completely. No other bond should be broken. Just the double bonds. Okay, just the double bonds. Nothing else should happen to the rest of the molecule. If it's a cyclic structure, keep it as it is. Nothing should change. Just focus on the carbon atom. So let's continue with this. Most of the questions would be just like this. I mean, they would be slightly more tricky because they're going to mix it up with other reactions as well. And I think, what was the question? Let's go back to the question. So he was talking about cold dilute acidified magnate 7,9. So cold dilute acidified. So you have this molecule. It's C double bond C and CH. So let's quickly do this. There was a carboxylic acid group.
Sir, इसका आंसर A आ सकते हैं.
So there was a carboxylic acid. So cold condition, it's mild oxidation, right? So there's going to be an OH group added over here, and there's going to be an OH group that is added over here. and the double bond would turn into single bond. It will not completely break. So I think it's going to form a diol. So you don't even have to draw this. The only diol in this entire thing is the first one. So the answer is A. I mean, this is exactly CHOH, CHOH, and there's a COH, CHOH, and then there's a COH. So that's exactly the same. So let's continue with more. Yes.
Sir?
When
Yes.
do we put the you know, like when it's branched OH, when do you put it into brackets? And when
Achha, wait,
like when you're writing
that one, like how to write the condensed version, right?
yeah,
Now
yeah.
when you're writing the condensed version, all you have to do is like if there's any molecule, right, you just start writing left to right, right, in any direction. So
Yeah.
you just start writing what's next to the first carbon atom, that's COH, right? Then what's next to this carbon atom? It's CH, and any branch is written in brackets. Like there's an OH branch that's coming out of it. So that's the next carbon atom, right? Then you have the third carbon atom. What's next to it? It's directly bonded to an H, and then there's an OH branch, right? And then the last one is COOH again. So anything that's branched, that's put in brackets. Is that clear?
Yes, sir. Okay.
And also remember, I could have gone in any direction. So branches are relative. Like I could have started writing not this one, but just the thing is that let's do another one. Let's just quickly do another one. So let's say I have an OH, and this one also has CH3, and this one has another OH, and it's got an H, an H, and this has 3 H's. So pick any direction. Let's go left to right. So the first carbon is with 3 H's, the first one. The second one is the second one over here. That's with 2 branches. There's an OH branch, and then there's a CH3 branch as well. So you're going to put 2 brackets now on the second one. The third one is CH2, and OH is part of the chain. So, I mean, there's no need to put it in a branch because even if you don't, it still looks. The reason you put brackets is just to differentiate, because this carbon atom, if you hadn't put brackets with branches, they would have gotten mixed up. Is that clear?
Yes, sir. Understood.
So the last bracket isn't really needed. Like even if you don't put those brackets, you're not mixing up with the OH with anything, right? So that's what you do. Make sure you know this. Make sure you know this, how to write this in this form. So let's continue tomorrow then. Okay.
Sir?
हाँ जी.
Sir, वो पिछला Saturday का lecture.
वो भेजो. Okay. Love is.